Yeah. Today we'll be speaking about bit stuffing, which is also commonly known as positive justification. Bit stuffing is the insertion of non-information bits into data. These stuffed bits should not be confused with overhead bits. So in our code, what we initially begin with is we read the input text file. The input text file will contain the destination address, the source address, the CRC, and as well as the data we input. The code which is given here, it basically separates all of these into individual components from a large string. Next, what we do is, using the data which is given to us is generally in ASCII format. So to convert this ASCII to binary, we employ a small function with a very simple divide by 2 logic. You collect all the remainders after you divide the dividends you get to form a proper binary number. Now with this binary data that we have, we try to calculate the checksum. The purpose of this checksum is to check for errors once we finally get to check for errors on the receiver side. The checksum is calculated by dividing the data into blocks, each of length 8 bits. In the checksum, we add up all of these blocks using a normal addition, not this XOR addition, and whatever final value you get, this is appended onto our final HDLC frame. After this, we initialize our count to 0. The purpose of this count is to calculate the number of number of consecutive ones in our program, in our data. Once a count of 5 has been reached, according to the theory of bit stuffing, we are supposed to insert a 0. So the bit stuffing algorithm, bit stuffing function, it makes sure that once we encounter 5 ones, we pass a 0. We do not replace any existing bits, we just add an extra 0 bit. Followed by this bit stuffing, what we try to do is we try to arrange our entire destination address, source, the bit stuffed value, along with the checksum into a proper single array, which is then transmitted. This single array frame is identified by a limiter and delimiter, which are both same 1 byte values each. Yeah, this is the algorithm for the checksum, which I just explained. We transmit the entire data sequence, the destination, the limiter, the destination, the source, the binary value of the stuffed data, the checksum, and the delimiter together. This value is again on the receiver side. We destuff this value. We again separate the limiter, delimiter, destination, source, and from the binary value of the stuffed data, you again employ a counter. After every 5 ones you receive, you have to remove a 0. In the stuffing case, we added a 0. In the destuffing case, we remove a 0. And once you get your final data, binary data, we again employ a checksum algorithm over here, so that you can check for errors. The final binary data which we receive after destuffing is again divided into blocks of 8. Following which we add up the blocks using normal addition. Now whatever checksum value you get over here is checked with the previous value which we have received from the entire single array. If these two values are equal, we deduce that there are no errors no errors have occurred in the transmission process. If there is a difference between the checksum values, we deduce that there are errors in the transmission. You find the error status using the checksum. Now once we have our binary decoded message sequence with us, we have to convert it back into ASCII, following which we write it into the output file. The output file again contains the destination address, the source address, as well as the ASCII value. So coming to the simulation of the sample code, this is the input text file which we feed into the program. The destination address can be seen over here, as well as the source address. The data we are entering here is 0 _0 _0. with the error status as 0, which means that there are no errors initially. Now once I run the sample code with no errors, we see that initially the ASCII to binary algorithm is employed, where the ASCII values in decimal are converted into binary values. Next, the checksum is calculated, followed by the framing of the HDLC frame formation. The delimiter along with the destination address, source address and data, checksum and ending delimiter are padded together into a single array. Now the bit stuffing is employed. We see that the count keeps on incrementing, and once a count of 5 is reached, as you can see over here, 3, 4, 5. Now an extra 0 which is red in color has been padded into the data. The bit stuffing process will continue till the ending delimiter. Another 0 has been padded here after 5 ones have been obtained. Again we see that there are other 5 zeros. And now in the destuffing process, the reverse occurs. Once 5 ones are obtained, the extra padded 0 is removed. It's about to come up. You can see that 0 has been skipped, which has basically been removed, and you continue on with the frame sequence. Now after the checksum has been recalculated, the obtained data is converted back into an ASCII value, and you can see that the user data we have obtained over here is without any error. So coming to the user code which I have written on my own, once we run the process, again as usual the ASCII to binary conversion happens first. Once the input file has been read, next the checksum has been calculated. The entire HDLC frame is formed in a single array, where the delimiter, destination, source and data, checksum and ending delimiter are appended. We can see that the bit stuffing process has begun, and the count variable is used as a measure of when to append a 0 or when to append a 0. After 5 ones, a 0 has been appended. Again a 0 has been appended after 5 ones. And now again that we have 5 ones, 0 has been appended. The destuffing process has begun, where the reverse of the previous process occurs. The first stuffed 0 has been removed over here. Following which the second and third stuffed zeros have also been removed. The net checksum is calculated again, and now the ASCII to binary conversion happens. The binary to ASCII conversion happens, and you can see that the received data over here is again the same as the data which is sent. Now we'll be running the code with an error. ASCII to binary conversion takes place after the file has been read. The HDLC frame formation. The bit stuffing process. We see that the effect of the error starts to come in only after the data has been passed through the channel. So basically during the bits destuffing process, we expect to see the effect of the error. This is mainly because noise in the channel corrupts the data which is being sent. We can see that as in the previous example with no error. In the bit stuffing process, we have 3 zeros appended after the 5 consecutive ones. Again, the reverse of the bit stuffing process occurs over here. As you can see here, in the received data, our fourth character has basically been morphed. This is basically due to an error which has occurred in the channel. So successfully we have learned how bit stuffing is employed in the data link layer of the communication channel. This is Aditya Mandapaka along with Anudeep presenting this assignment to you.